why the evaluation is incorrect. Use a calculator to help you to attempt to evaluate. Determine whether the utility gives the correct answer. So this was really quite a nice problem, but you guys just looked and said, it can't be done because the function's not defined at 0. But the whole section is about what you can do when the function's not defined. So, you say what?
You wanted us to work the entire system.
Yes, I wanted you to work the problem out.
Explain what you did wrong.
So there needed to be a split at 0. And what the little definition of improper integrals says is you need to split this up into 2, and that from this piece you're going to take the limit as you approach 0 from the left, and this piece you're going to take the limit as you approach 0 from the right. And then you would work those out. But that's not what you guys wrote. You just wrote, can't be done, improper integral. And I'm going, no, the whole section's on improper integrals. Okay, do you see? And I wrote just about every one of you a little note about my concerns here. So now I don't know about this one when you put this into the calculator, whether it turns out, I'm guessing it must turn out to be -2 in the calculator. I did what? Oh, thank you. So 1 over x squared, we're integrating with respect to x. We're running from -1 to 1. Now that's what I got.
I got tolerance not met.
Oh, tolerance not met, okay. So even though the directions in the book say use your calculator to help you do it, you would now maybe be inclined to assume that it must be improper and it must diverge. But let me just caution you about that. This is not a place where your calculator is as trustworthy as it is normally. So let's finish it off for fun.
It was just we have to down number 37 as well. Can we do the substitution with the b?
Perfect. So we've got the limit as b approaches 0 from the left of -1 to b, x to the -2 dx, plus the limit, let's do a. A approaches 0 from the right. So there's the 2 limit statements, and John, your limit statements were beautiful. If anybody has trouble with the limit setups, talk to John.
Put this from A to 1.
Oh, thanks. A to 1. A to 1. And so now?
So then it's going to be x2, or x1, it's going to be x -1. Right? X -1 over -1.
-2x to the...
Hey, you take
negative
2x
divided.
negative x to -1 to -3.
We're integrating, not differentiating.
Okay, sorry.
Negative x to the -1, which probably you'd be happier writing as -1 over x. All right, now, I also wrote you all a little note on another problem that was split into 2 parts. You all proceeded to do both parts. My point to you is, by the definition, if one piece of this diverges, that's the end of the problem. So let's not be overly enthusiastic. Let's work this piece and see whether it converges or diverges. If it diverges, we're finished. So you all, I think, have that note on number which one? 11? 9, 10. Yes, you should all have a note on number 11 that says something about you only needed half of this work. So we'll finish this half. Let's go over here. we've got then the limit as b approaches 0 from the left, negative 1 over b minus negative 1 over negative 1.
Bottom, which is 0, so it goes to infinity.
This piece went to infinity.
Negative infinity, I guess.
Let's see, 0 from the left is actually negative, and so the negative divided by the negative, it'll actually, but the main thing is it diverged, right? So this made a nice number, don't really care because, oh, and somebody wrote to me that infinity plus 1/4 equals 1/4. Could I be your banker? I'd like to hold your money for you because you think that $100 plus a quarter of a dollar is still only a quarter of a dollar. No, infinity's going to eat up whatever is over here. In this case, it's a finite amount. So what happened was this piece diverged, which means I don't bother with this piece, don't care whether it converges or diverges. By the definition, you're done now. The problem's finished. Okay. Now, how did the fellow in the book get this -2 that he was trying to lead you to believe was the answer?
Did you take the limit twice?
You probably just took the limit without separating them or something. Just kind of.
I think he just, he wrongly
Think
integrated
worse.
it. He
What would be the
integrated it.
most upsetting to the calc teacher?
Just ignored that the function.
If he ignored that the function was improper to begin with. So what they did was they took x to the -2, integrated to -1 over x, evaluated from -1 to 1, and that gives you a -1 over 1 minus a -1 over a 1. Oh.
Minus
Negative
-0
1
out.
over 1 minus
Actually, no, the
a
first
negative,
one,
wait,
yeah,
wait,
would be
wait, one more
-1.
negative, minus a -1 over 1, so we get -1 minus 1, and that's what the fellow did to get his wrong answer. Okay, so he just blindly went ahead and it,
Can you just cross that?
which is what you were talking about before.
Yeah, I was just
If
saying.
you just went ahead and did your integration,
That 0.
and skipped the fact that it was 0 at all, you'd end up with an answer of -2. So this was 15, and it was quite elegant if you took the time to really investigate what was going on in the problem. Yeah.
Can you cross that? Make
Cross
sure
what
it's
off?
wrong. Otherwise, I'll
Oh,
be like, what do you shortcut? There we go.
bad.